You're watching Electrical Engineering Lectures channel. For more videos, please do like, subscribe and hit the bell icon for the latest notifications.
Welcome to another video. The last video is all about the magnetic contactor, how the magnetic contactor works, what are the different parts of a contactor, and what type of control and power wiring is used to on and off a magnetic contactor. In this video, I am going to tell you in details the main reasons of failure of magnetic contactor. The failure of the contactor is a common event, but often the reason for the failure is not understood. Like all other applications, whenever a contactor is subject to a stress outside its range, it will eventually lead to the failure of a contactor. An understanding of a possible cause of an earlier failure is helpful in evaluating failure in service. The problem with the contactors manifests in three forms. The first failure is the failure to close. That is, whenever you want to energize a contactor, it fails to close. The second type of a failure is when the contactor fails to open. And the last type of failure is the most severe one, and that is a flashover of a contactor. So I will explain all these reasons of failure in detail. The first one is whenever a contactor fails to close, the main reason always comes with the coil. That is, something bad happens with the coil. The first reason of the coil failure is aging problem. In AC applications, the windings are subject to forces which can cause very slight movement over the time. So, over a long period of time, any movement can result in sufficient damage to the coil to cause an insulation breakdown. The second reason is the most common, which is the frequent operation of a contactor. This reason is also leads to the coil failure. This is directly related to the temperature of the insulation material used for the insulation of a coil. The normal expectation is that the life is half for every 10 degrees C increase in the temperature. The frequency of operation can cause the coil to overheat as the pull-in currents are much greater than the hold current. The next reason of coil failure is the magnetic system. If the applied voltage is too low for the magnetic system to close, the coil can also burn out, as it is still possible for the coil current to be at a higher level than the normal closed state. The last reason is also very common reason of a coil failure, and this is the instability in the voltage or the voltage transients, and this reason is absolutely beyond the control of a user. Now let us have a look at the reasons why the contactor fails to open. The main reason for this is the contact welding. So what does it mean by contact welding? It means that the incoming contact of the contactor melts because of these reasons, and it will then weld with the outgoing contact, due to which the magnetic system failed to open the contacts, and this is called contact welding. There are several reasons of this contact welding. The first one is the mechanical shock. The mechanical shock can cause the contacts to open and produce arcing and a weld. Control cabinets mounted directly on a machine may be one of the causes of the mechanical shock. Also, a large contactor mounted next to the small one may also transfer sufficient shock to open the contacts of the small unit. The next is the very common reason of the contact weld, and this is overcurrent. So The overcurrent means different forms. First one is the overload. If the contactor rating is less than the connected load, it will ultimately result in contact weld. Also, inrush current, if larger than the rating current of the contactor. The next reason is the breaking current larger than the rating current of a contactor. And finally, the heat produced by an arc under fault condition causes the severe weld. The next reason of the contact welding is the contact chatter. Problems with the control circuits sometimes produce a burst of rapid opening and closing of a contactor. This chattering will greatly reduce the contact life and can cause a weld. Another reason of the contact chatter is the electronic devices that are very common source of a chatter, as they can be sensitive to the electrical interference. So these are the main reasons of a contact welding, due to which the contactor, once weld with each other, fails to open. And the final reason of the failure of a contactor is a flashover. The compact design of a modern contactor means the phase separation is very small, as the compartment or the frame of the contactor is getting smaller and smaller. So what happens if there is a loose connection between a phase? It can produce an arc which can quickly transfer into phase-to-phase fault and ultimately result in internal damage to the contactor. Another reason is that some contactors that already have reached their end of life can have significant deterioration of the insulation between phases, and in the extreme case a flashover may result. So this is all about the main reasons of failure of the contactor. In the next video I'll come up with the main solution, how to avoid these failures by applying proper maintenance procedures of the contactor. So stay tuned and keep watching and keep following, and don't forget to subscribe and like the videos. Thank you for watching.